everyone, I'm Angel Ong Si.
I'm Kasin.
My name is Lim Zilo.
I'm Tonjamin. Yes, Team Microscopic from Sri Lanka. Today we are going to talk about the osmosis.
Before we start, we have to know that our bodies are made of trillions of blocks called cells, just like many Lego bricks combined together to form a Lego house. They are so small and cannot be seen by our eyes, but we can see them under a microscope. Everything, including the pen we use, the water we drink, and our body cells are made of many tiny balls called particles. In solid, particles are fixed at there, but in liquid and gas, particles are always moving because of heat energy.
To explain osmosis, we need a shoebox, paper box, hair dryer, marble and ping pong balls, hot glue gun, scissors and cutting knife. Cut the paper box into many small cuboids which is 2 cm in length and 10 cm in height. Prepare the rectangle papers which is 1.5 cm in width and 12 cm in height. Measure and fold both ends of the paper. These cuboids are empty inside, so close them up by attaching the folded paper with cello tape. Attach a complete cuboids in the shoebox by using hot glue gun. The distance between each two cuboids must be larger than a marble but smaller than a ping pong ball. Make sure the two hair dryers used have the same wind power.
Let's imagine that the left part is our blood, the right part is our body cells. Every cell has their own fence called plasma membrane, which is represented by cuboids in the middle. The fence allows certain gas only to enter the cell. The marble represents water particles, while the ping pong balls represent glucose particles, which are sugar. Put equal amount of marble in each part and more ping pong balls in the body cells compared to the blood. Because of heat energy, water and glucose particles are always moving randomly, but marble and ping pong balls don't. So use two hair dryers to blow them on the both sides, making them move randomly in any direction with the same speed.
There are too many ping pong balls, which are glucose particles gathered inside the cell, so they try to diffuse. In the other words, they try to move out of the cell until being scattered equally inside and outside. However, they are too large to move through the fence. Only marble, which is water particles, are small enough to move across it. Water particles inside the cell are weaker because they stick with more glucose particles, while water particles outside are stronger because there are less glucose particles. Thus, water outside will push themselves into the cells until there are enough water particles with the glucose inside. Finally, we can say that osmosis happens and our body cells will get enough water because they also need to drink like us.
Here's a proof in real life. We need a potato, sugar, kitchen towel, and cutting knife.
Potato, 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 potato.
Potatoes! Cut 6 cm times 2 cm to make a cavity at the center of the potato. Wipe the cavity of potato by using kitchen towel.
We'll have the cavity made in a potato with sugar.
In this little experiment, the situation is reversed. There's less sugar inside the potato, thus the water inside is stronger than water outside, pushing the cell out of the potato. That's why we can see there's water in the cavity of the potato after a while.
Last but not least, I would like to say that our teaching tool and experiments are cheap, safe, made of recycled materials, as well as requires minimal supervision.
Above is all of our presentation.
Hope you all like it.
Thank you.